while trying to explain all this to myself, to convince myself that I understand it too, I've come to believe that this is impossible to explain from a point of view in front of or behind the ball. We really need to look down on it. So I've been talking about this point of view where the ball is coming at you. I now want to look at the ball from up here and then look at the way the flow goes around the seams. That's what's going to be important here. So imagine that you're looking at it from here. And so now we're looking down on the ball like that. Home plate is over here, and the ball is moving towards home plate. And it is spinning, and if I'm lucky here, I can figure out which way it is spinning. Yes, that would be right. Okay, so what I want to, really the most important orientation is here. Now, obviously, whatever happens to the ball depends on the entire rotation, but different things happen at different orientations, and the effect gets averaged together. So the one that's easiest to understand is this one. If the ball's in this orientation and it's traveling this way, so it's going to run into my finger, that stagnation point I talked about before is here. The air is going to hit this spot, and so half of it is going to go this way, and half of it's going to go that way around the ball. What's important is that in both directions it's going to encounter a seam. And when it does, the flow will become turbulent. It's laminar here at the front of the ball, and it's going to become turbulent. And the reason that we care about that is if the flow is turbulent, it is able to stay attached to the ball past the middle of the ball. If you read my stuff, you see me talking about boundary layers. That's the layer of air right at the surface. It's going to stick to the ball. It's going to go around the corner. And what we've discovered in our measurements, and there's lots of this proven on our website, is that these stitches on the back of the ball, here and here, tend to be the location where the boundary layer comes off. And that means the wake is right here. It starts at these two locations and it moves backwards. The important thing to this, the really crucial thing, is the pressure here is very high. It goes down as we go around the ball. It's changing everywhere, but it stops changing once the flow separates. So it stops changing here on the top and it stops changing there on the bottom, but those are at two different positions, two different axial positions. And that means that the pressure on the top and the bottom isn't the same. And that generates a force. That's the crux of it. And it's going to be a force that is generated in this direction, that if side to side, if you're looking down at the ball. So now let's look at the other orientations. What if it's like this? Well, at this orientation, now the air comes in here. It's going to not encounter any seams as it goes all the way around. It's going to separate laminar off of both sides, and there's no force generated from that because it's symmetric. If I go a little further, now again I got seams on the back of the ball, and I'm sorry, that's the front of the ball, back of the ball over here, and they're asymmetric, so that's going to generate that same asymmetric wake. So if you look at one of my recent posts, I did a full rotation of this and showed that most of the time there's a sideways force in the ball. There are brief periods where there's not, and that's going to average out to a sideways force in the ball. Now, one thing I still am struggling with is that this force is in the opposite direction of Magnus if you have a pitch that is thrown from a 3/4 arm slot, so that the ball is tilted a little bit as it goes in. And I believe that that's the reason that the famous Freddie Garcia pitch breaks so hard, because it doesn't have much Magnus effect because it wasn't spinning very much. I don't really understand what the point of having a force generated that it does oppose Magnus if you have a lot of Magnus on it. And I'm hoping Trevor Bauer can explain that one to me.